Hi folks, we're here today to share with you some very important properties of logs. Now, we're not talking about the long, round, brown logs, no. It's a different type of log that's very special, known as the logarithm. Learning and understanding these three properties of logarithms will help you in the future to solve complicated logarithmic equations. Thank you, sir.
In this video, we will explain three properties of logs and give examples of expanding and condensing log expressions. Prerequisites include a basic understanding of logarithms.
Afternoon. Our objective. After watching this video, students will be able to understand three properties of logarithms and use them to expand and condense logarithms.
Now let's get started.
The first property of logarithms we'll be talking about is called the product property, and it goes as following. Log base b of m times n equals log base b of m plus log base b of n. I'm going to take you through why this works, why it is what it is. So let's start with the left side. Log base b of m times n. So this b, the base of b, applies to both the m and the n. These two are being multiplied together, and we want to separate it so that these terms, these variables, have their own term, as seen here. So first, we just want to review the solution to a log is an exponent, and exponential and logarithmic, they're inverses, so we can expect them to have similar properties. So let me just give you a quick example for exponential. X to the second times x to the fifth. Well, what does this equal? We see that there's a common base of x, and the exponents are different. There's a multiplication symbol, so we know to add the exponents. So this equals x to the seventh. Okay, let's apply this to logs. So we want to separate this so that they have their own terms. So let's write log base b of m and log base b of n. Well, we see that they have like bases of b, and they're different arguments. The argument is right here, the m and the n, so we know to add this. Log base b of m, this is an exponent, and this turns into an exponent. Exponents, like bases, you add them. Okay, let me give an example. Let's start with the right side this time. Log base 2 of 8 plus log base 2 of 32. We see that they're like bases of 2. There are different arguments, 8 and 32, and there's addition. So what do? We multiply the arguments, 8 and the 32. So log base 2, we keep the base, time log base 2 of 8 times 32, which is 256. If you don't believe this, let's just look at what they equal. Well, log base 2 of 8, 2 to what power equals 8? That's 3. Log base 2 of 32, what is that? That's just 5. And log base 2 of 256, well, 3 plus 5 is 8.
Okay, so I'm here to talk to you about the quotient property of logarithms that states that log base b of n divided by m equals log base b of n minus log base b of n. So as Harris said earlier, logarithms are similar to exponents in that they're an inverse. So the solution to any logarithm is equal to an exponent. So that would mean that any logarithm, such as log base b of n or log base b of m, is equal to an exponent. So let's take the example x to the fourth over x squared. Now, according to our exponent properties, that would be equal to x raised to the 4 minus 2 power, which equals x squared. So logarithms, when there's a division in the argument, work the same way. So now you're ready for an example. Let's try log base 5 of x divided by y. Now, according to our quotient property of logarithms, that's going to be expanded to log base 5 of x minus log base 5 of y. Okay, so now you see how it works with variables. So let's substitute in some integer values to see how it works that way. So let's let x equal 25, and let y equal 5. Okay, so let's start with this side. According to our properties, or according to substitution, we're just going to substitute 25 in for x, so log base 5 of 25 minus log base 5 of 5. Okay? So this log base 5 of 25 is 2. And log base 5 of 5 is 1, so 2 minus 1 equals 1. This would be a fully simplified version of the logarithm as shown here. So, just to show you that this works, we're going to have log base 5 of 25 over 5. Instead of expanding, you can also just divide the arguments. So 25 divided by 5 is equal to log base 5 of 5, which equals 1. Notice that they're equivalent.
The third and final logarithm property of this video is the power property, which essentially states that log base b of m to the power of n is equal to n times log base b of m. To make this easier to look at, we're going to have log base b of n to the power of m, n equal x. So x is going to be x equals n times log base b of m. We're going to put this in exponential form, which means that it's going to be base b of x equals m to the power of n. Because we want m to be alone on this side of the equation, we're going to multiply both sides by 1 to the power of 1 over n, which is going to equal b to the power of x over n equals m. Turning this back into logarithm form, we have log base b of m equals x over n. Now we want the x to be alone, so we multiply both sides by n. All of this leads us back to this equation beforehand.
Now that we've gone over all three properties in this video, we're going to show you an example that includes all the properties. So we're going to take the log base 7 of x times y to the 4th over z cubed. Okay? Now if we apply all our properties that we've learned in this video, this is going to be log base 7 of x plus 4 times log base 7 of y minus 3 times log base 7 of z. This applies all the property, and this is known as an expansion.
Next, we'll do a short example when we condense logs. We have multiple terms and we want to condense it into one single log. Next, we need to identify what properties to use. We see that the log base 7 of n has a coefficient of 2, and the log base 7 of p has a coefficient of 7. So we're going to take this argument of n, raise it to the 2nd power, and take this argument of p and raise it to the 7th power. So we get log base 7 of m minus log base 7 of n to the 2nd power plus log base 7 of p to the 7th power. Now let's use both the quotient property and the product property to further condense it. So we see the minus sign here, so we know to use the quotient property and put this m over the n squared. So log base 7 of m over n to the 2nd. But we still have this plus log base 7 of p to the 7th. What do we do with that? Well, since there is a plus sign here, we're going to use the product property. So we know to multiply, since there's the same base of 7 as it is here, we're going to multiply by p to the 7th, the argument. So when we multiply, we just multiply in the numerator, so we're going to put p to the 7th. Log base 7 of m times p to the 7th over n to the 2nd. And that's how you condense a logarithm from expanded form.